Okay, so yesterday we have plotted the restricted sign, the sign. So let me write it down, right? And so here it is. Okay, so this is the function to recap. Okay, so this function we have in green. Okay, I made some adjustment to the color, so I just want to make sure. And I'll be using the same color tone for quiz if I do question you on quiz about this. Okay, so this is the sine x. Okay, this sine x, where the x is between. Okay, so the x. Okay, the x is between negative pi over 2 less than equals to, well, that's the hard part. The software doesn't allow me to do that nicely. So never mind. So I'm going to just continue. I'll just write it down on the top, okay? And I'm going to summarize. I'm going to put a table as usual. Okay. Is everybody awake? Did you have a good night's sleep? Sometimes it seems a little bit trying to get up in the morning, right? When you might wish to sleep in. Is that right? But let me tell you, this morning I was just thinking of you guys. You guys have been doing amazing, okay? Getting up every morning at 8 o'clock to attend the class. And this is very good. This is going to be very, very good for you, okay? Now, this is the function. This is the function, right? So all those other words, people call it the one-to-one version of sine, or the restricted sign, or constrained sign, whatever they say. The better description would be just attach the domain the input is from. Okay, that's the domain. And of course, the range, I said I'm going to make a table, right? I'm going to make a table. Let's do that. Okay, to recap what we did yesterday. The sign we're talking about is this new function. This is a new function. Even though it go by the same name, it's a different function. It's a different function. Its domain is between negative pi over 2 to pi over 2. So this description is kind of redundant, okay? But I'm leaving them there. Range, of course, is still -1 less than equals to sine less than equals to 1, right? And the other one commonly used, which you guys are familiar, is this interval. Okay, interval is good. It's good to understand, but oftentimes you need the sign. You need an algebraic version of it, which is inequality, right? So we have the curve for this function. So let me put side by side, right? Insert the row. I'm going to put the curve right here. Okay, so yesterday we plotted the points. We marked the points. I give you homework to do that all over again, right? And this function is 1-to-1. It has inverse, and its inverse, okay, its inverse, if this is called a G, and its inverse is called a G of inverse, right? And we talk about that. The name doesn't matter. The name didn't matter, okay? And that curve is right here. And we practice with two tables. Okay, we practice two tables is how to express those points properly, what it means, right? So on the graph, I have to say the marking on my graph is not perfect. Okay, I wish it to be a little bit better, but I will spend time to, because when I adjust it on one size of fonts, when I change the size, it actually makes them, it doesn't change on, perfectly. So I spend a lot of time doing this, but anyway, without further ado, let's just move forward. Okay, just move for 175%. So we make sure you see the negative sign here, right? So from the outset, right? The domain range, right? So this domain, if you use interval notation, that will be -pi/2 to pi/2 for the restricted sign. You guys give it all kinds of names. And I assume that our professors, my peers, were calling these by all these different names, which is all fine, Okay, there. Remember the two tables. You guys must do the two tables all by yourself to learn how to use the notation. Okay, do you guys hear me? You must, okay, because I've seen so many mistakes, too many, okay, from some students. I don't know who, but there's always a pretty good percentage of students. They didn't know what they're writing. They keep telling us, well, I understand, but I don't write it wrong. We write it correctly. Well, that doesn't count, okay? We cannot assess you by going into your brain. We cannot go into your brain. We have to look at what you write it down, okay? And everybody is assessed that way. Okay, so commit yourself to make sure you are familiar with the notation in the two tables we will work with, okay? So now, the inverse, what we want to emphasize is that the inverse, the domain for the inverse, right, which is, this is the input, right, and add another row, which I want to emphasize. I've been preparing for this moment ever since the beginning of the semester. Right? We talk about, well, ever since we started addressing trigonometry, I was talking about, at that time we're using A, right? We were using A. It doesn't really matter, right? It really doesn't matter. So now we're using X. They're just merely a placeholder. You need to get used to the idea that these variables, no matter how you name them, they're just a placeholder. That's why we use X more, because X is a placeholder. If you change it to a heart, it doesn't make any difference. Say, for example, if I want to change that to heart, is that going to change the nature? No, it's not going to change anything. The definition still applies. It's just a symbol. Okay, so don't get confused by these symbols. Okay, don't get confused by these symbols. Now, if I use heart, then this heart will be the input. So this heart must be angle. So it doesn't matter you use A, you use heart, you use X. The nature of the function, the rule determines what kind of input it takes. Okay, whatever number you give it, it will be treated as, as radians. Well, sometimes degree is fine, but it's just angles. It's just a measurement of angles. It could be radian, it could be degrees. So it's just a symbol, okay? So the heart goes into the sine, right? The sine function. It produces a ratio, okay? So just when you see sign of something, you just know this is a ratio. What a ratio is it? If you could dig deeper, you'll be quoting the definition, and that's going to be y/r. Okay, so in your mind, that's a ratio. Okay, so now you just have to, I'm just going to emphasize that. The inverse function, however it's being called, however it's been called, okay? The inverse function, right, over here, right, it will take ratio as input. So whatever the input, if I decide the input is going to be called x, x will be a ratio. So this guy will be the ratio. Okay, I pointed out some mistakes yesterday, right? Some people just don't understand what they're doing. They would write things in the wrong way. Okay, so if you forgot those mistakes, go back to watch the recording yesterday, right? And now it's from ratio to what? To angle. So the output is going to be angle. Okay, what angle? But this time, the ratio has to be what? Has to be, because in this piece, right, the ratio will be the domain. In this green, the angles are the domain description. Do you follow me? So in this description, the input is described by the domain requirement. The output are ratio. Is a ratio. Ratio is been between -1 and 1. And these two, domain and range, one's domain is the other's range because they are inverse function to each other. Therefore, the domain for these ratios, which are input for the inverse function, okay, is going to be between -1 and +1. One's domain is the other's range. So I'm just copy and paste. You guys see that? Okay. And next, this input x here can also be written in some other form, such as similar to this, right? Which is going to be -1 less than equals to x less than equals to +1. Is this x and the other x the same? Of course not. This x represents angle and this x represents ratio. It is determined by the rule that applies to it. Okay, so when you write it as arc sine x, or you write sine inverse of x, so I was telling you this is the popular notation, and the latter one becomes increasingly popular, even though, right, I could be using the same name. I can be using x. Okay, I can totally use x because it's so convenient to use x, right? Because I can totally do this. In fact, you're going to see this a lot. But you need to understand this x, the nature of this x is determined by the rule that apply to it, which is the x has to be angle. And this other x, right, even though it's also called x, it's merely a placeholder. I can name anything I want. I can make it heart, I can make it spade, I can make it, any kind of symbol I want. I can make it look like an apple. Right? And this x, the nature of this, the value, what kind of value x can be in this situation is determined by the nature of this function. If this function, because this function is an inverse function to, g, therefore, x will always be regarded as a ratio. So if this x and this x, they're totally different in nature. And this is the angle and this is ratio. Do you guys follow me? You are going to see a lot. But what determines the nature of these symbols? The function immediately applies to it. The function that immediately applies to it. the function that immediately applies to it. I'm saying this 3 times. You should write it down. You should write it down. Okay, so as a result, because this function calls for ratio as input, therefore this x is ratio, and this x also has its own domain. That domain can only be between -1 and 1. So if you, yesterday I have you guys use a calculator, right? If you input a number outside this domain, your calculator will not produce any value. It will tell you it's error, right? We saw that yesterday. And what it produces, the output is going to be an angle. So you can see angle ratio. So the function is from, G function is from input angle, output ratio. Its inverse is input ratio, output angle. That's the inverse we are talking about. And isn't this consistent with what we have always talked about inverse function? It's just a swap. It's just the swap of input and output. You guys follow me? It's a swap of x, input output. Just like as beginning, we talk about inverse, right? In the process, we're finding inverse. The first step, what do? We swap x, y. And what's the implication of it? The implication of that swap involved the domains range swap, and there's a lot of implication in that process. And yesterday you also see that swap also caused the points, right? The points on one graph, right? Pi over 6, 1/2 is swapped to 1/2 pi over 6. Do you guys see that? Do you see all these swapped at this point? This point pi over 2, 1, now swap to 1, pi over 2. Do you guys see that?
Yes.
This is what I see. This is 1-to-1. This is the visual of 1-to-1. And we saw that with exponential log function. And we saw this one more time. Well, 2 more times, 3 more times, all over again. That's what I want you to see. That's what I want you to see. All right. And I trust you guys have plotted the points, because I will have quiz to make sure you guys really can do this well. Okay. So with that said and done, let's look at the range. Range. What will be the range? One's domain is the other's range. So the range for ArcSine is going to be between -pi over 2 to 2, and I'm going to give you 2 more forms. Okay? The 2 more forms would be this guy, okay, between -pi over 2 and less than equals to +pi over 2. Okay, I'm kind of making some adjustments. So this is the other form. You guys see that? And one more form. Okay, ArcSine of x, the absolute value is less than or equals to pi over 2. Okay, they are all the same way. What does it mean? It just means that in this inverse function, right? We talk about the domain is horizontal span. Horizontal span. The picture horizontally span between -1 to +1. Right? Horizontal span. Horizontal span. The picture is in this box. The vertical span, this is between, you see, this is between -1 to +1. The horizontal span is between -1 to +1. So the curve, the curve always bounded vertically by -1 to +1. Vertically is between -pi over 2 to pi over 2. It's between -pi over 2 to pi over 2. That's the vertical span. Okay, and that's the range. That's the range. Okay, forgive my picture. This it's not perfectly straight, but it's meant to be straight. Okay, so your curve is in that box. And what it means that curve is in the box. Yesterday we talked about the no man's land, right? The no fly zone, no man's zone. You cannot get in there. You're gonna step on some, step something, get yourself killed, right? Don't get there. Don't get there. Okay. All right. So without further ado, so there's so much involved in this process. So much involved in this process. Now we understand that these two functions are inverse to each other when we put them together, right? When we put them together, what do we see? We see even better. Did I show you this picture yesterday? I think we did this picture where I did it after class. Okay, so in this picture, you can see the green curve is the sine. The green curve is a sine, okay? I illustrated it over there. The green is the sine, all the dots on the green. The red is the arc sine. Okay, so the green and the red. There are some pieces look like they kind of overlap, but it's still, they're completely two different functions. Okay, so you can see from the points. Okay, you can see from the points. And there's this red dots over here. Okay, let me make a pointer here. Look at this dots over here. Right, there's a red dot and there's a green dot, right? They're very close, but they're not overlapping in any way. One point, that the point on the red is input ratio, output angle. The green input is ratio, output is angle half. And at the highest point of the red, input ratio, output angle, input ratio, input angle, output ratio. Do you guys see that? All of this is to emphasize to you what we just emphasized. So ultimately, in most of the cases, to assess you, we will write the algebraic form in the table, okay? I assure you, most professors, they probably will not do the graph in such details in class, and they may not ask you to identify the points like I do, which I will, okay? But you will be eventually assessed, okay? You will be eventually assessed on what? You'll be assessed on writing these tables, okay? Some of these tables. These are the things you need to be able to write correctly and properly, and from which we assess if you understand. Do you guys get me? I do these pictures with you because I want you guys to have that visual. Okay? Have the visual, and you write these down. You write these down over and over again. You can see it's always the function input, output, and the whole thing is output, right? The function, the input, and the whole thing is output. The function, the input, and the whole thing is output. The output is such. You guys, so it's very consistent. It's very consistent. It's what we've been always talking about, right? F of x. F of x. So all of these in the columns, they are special cases of this writing, Do you guys see that? The rule of the function on the input, it produces output, which is f of x, like we have always addressed. Okay, so these are the concrete form. So x as input, right? And produces output. F of x. You guys follow me? Yes?
Yes.
Consistent, completely consistent. okay? And once again, you can see, am I repeating myself too much? I think I'm repeating myself too much. And the function determines what input it should take. Okay, and the function determines what input it takes. If you evoke the ArcSine, whatever number follows will be treated as ratio. If you evoke sine, whatever function you input, it will be treated as angle. If that angle is written as, without the degree symbol, and then it will be treated as radian. If with a degree symbol, it will be treated as degree. Your calculator has that intelligence because it was built in. It was built in. Okay, but they will do the domain check. They will do the domain check. Say, for example, for the ArcSine yesterday, we have demonstrated that if your input is larger than 1 or smaller than -1, your calculator will give you an error message. Will give you error message. Okay, so I think that's enough to recap, right? So I cannot urge you to do the homework enough. Okay, those are the homework exercises I have put up in the homework session. Okay, so let's go back. So what else goodies is there? What else goodies there, right? So we recapped what we did yesterday, right? Recall that we had a property, right? And this is the property. Let me save this file. Right? It's kind of slow. I'm sorry, what's going on? Hold on, let me see my network. Is it slowed down? Okay. Oh, the change of net. Okay. Do you guys hear me? Do you see me?
Mm-hmm. Yes.
Okay. Yeah, the network is a little slowed down. But anyway, so what else goodies is there? Well, this is the real thing. This is the thing that you guys are going to use, okay? So if, remember earlier on, we used this property for the exponential logarithm function, right? But this applies to any pair of functions that are inverse to each other. So if f is 1 to 1, right? Its inverse is f of inverse. Okay. And they each have their own, their domain range correspondence is a set. The domain range correspondence is set. Then we have this beautiful property. We have this beautiful property. Is f inverse. Okay, some textbook write it this way. And then elaborate. Okay, for x in the domain of f inverse. All right, and f composite, f inverse composite f. Remember we talked about this before? That equals to x for what? For x in the domain of, okay, domain of f inverse here. And over here, that's going to be the domain of f. Remember this property we did before? We did that with exponential logarithm, right? If you have forgotten, go back to review those recordings. This week I will have a quiz to review that part, to review exponential log. So you're gonna have 3 quizzes, okay, 2 more to go. Okay, so my homework is to make up that 2 quizzes, and your homework is to expect that 2 more quizzes, you know, to work for, okay? Now, these 2 properties still apply in our situation. These 2 properties still apply in our situation, okay? Let's see how it applies. So in our situation, right, what did we have? I'm going to bring that table that we had to work with us, okay? So I'm going to bring that table with us. I'm doing very slowly here, maybe too slow. But I believe this piece of lecture is worth you watching over and over, just in case, because you will encounter problems, all right? So in the situation that we have G, okay, let me make it 175%, right? We have the G, right? It applies to G. Let's see how it applies to G, okay? So let's do this together. So in our situation, are you guys writing it down with me?
Yes. Yes.
The F turn into G. Yes? That's an easy substitute, right? That's an easy substitution. And then what is, okay, so let's write this in a little bit more details, right? So G inverse of X, right? We talk about what it means. And that's going to be true. And this guy would be G of inverse of G That's true. So if this is true, right, it applied to G, it is going to be true. I merely just apply the meaning of composite, right? So take these 2 on the side. So I'm going to take these 2 on the side, right? So F changed to G. Take these 2 on the side. So let's see what we will produce. Okay, everybody follows me, right? What is our G? G is sine. G is sine. So G is sine. You guys see that? But this sign has a restriction. This sign has a restriction, right? And that also comes with it. And what's the G inverse? Arc sine. Okay, so we can remove that X. For what? For X in the domain of G inverse. What's the domain of G inverse? What's the domain in G inverse? From -1 to +1, right? We just talked about that box, right? The domain is a horizontal span between -1 to +1. So what would that be? You see how naturally it comes? It's just a special case. It's just a special case. Do you see that?
Yes.
And G inverse, arc sine, right? And what is G? Sine. For X in the domain of what? Of G. What's the domain of G? Between -π/2 to π/2. If I use this notation, I will use the, you know, the interval. So that's what we got. And what are these? What are these? I want you guys to look at the notes for trick 7A. Look at trick 7A. That's your homework today. And for this,
Does that mean the
trig
non-max?
7A.
Okay. Could go the other way.
Okay. Trig 7A. What are these? Did you guys find trig 7A? On trig 7A, there's an exercise big table and there's a smaller table on the top. And these two are the first two items on the very top. Do you guys see that? That's where it came from. Do you follow me?
Mhm.
All right. So let's see how it applies. Okay. And of course, this table of exercise involves a lot of, so I'm going to put this in a more compact form for convenience of transportation. Okay. Convenience of transportation. All right. So I'm going to put this one over here. I'm going to put this one over here. Okay, so the whole thing on here. Okay, I'm making some adjustment. Did you guys find 7A? Did you guys find sign 7A? And of course, I have them all mixed up, right? There's some sine, arc sine, arc cosine, arc tangent, and so on and so forth. And now we're going to focus on the arc sine combination, okay? Sine, arc sine combination. Okay. There's some illustration to be made because at the beginning when we cover these topics, right? We said when you see sine, it always refers to the sign as we know, which is domain is all real numbers. Domain is all real numbers. Okay. So what will happen is that now we have this nice property here, right? We're gonna work with sine. We're gonna take some examples and work on trig 7A. On the other hand, this is the time I'm going to bring the picture and bring sine function into the picture, into this summary column. Okay, so I can give you some, I hope it's a good and thorough summary. Okay, so I'm going to make another column. Okay, I'm going to make another, wait, that's not column, that's row, column, okay? Column over here, okay? This column, okay, on this column, I'm going to put a sine function in place. Okay, I'm going to call it F. I'm going to call it F. Everybody know the sine curve, right? It's at your fingertips. There's so many software that produced it. Okay, there's so many software that produced it, right? Domain, what's a domain? From negative infinity to positive infinity. And the range, what is the range? All of these, no change. As far as the curve goes, right? So I'm going to show you the curve. I'm going to get you a piece of curve. And this time I'm doing the curve, I'm going to do this. Okay, so let me do the curve on the sides, okay? Did everybody find trig 7A? Yes? In your notes. Okay, so y equals to, I'm just going to evoke the graph of sine, okay? I'm just going to evoke this.
Honey, do you have class right now? Baby, do you have class? Okay.
Would you guys mute, please? Okay, so I'm gonna have the curve of sine right here so we can have some ideas about what we are talking about. Okay. So three functions. And next, I'm going to plot the curve. You should get this curve at your fingertips. Very easy, no problem, right? Let me make a little adjustment so that it looks a bit, cleaner, all right? So this is the curve we call sine curve. By this time, we are pretty familiar with, right? We're pretty familiar with it. And I'm going to bring this curve to the top, to this table. Right? So we see that table here, right? The three curves. They're completely different three functions, okay? These two functions are inverse to each other. And this function has no inverse, okay? No inverse. What's the difference between these two? Domain. The difference between f and g is domain. However, because they have the same name, if we mention sine, if we ever mention sine, if we don't specify the domain, it always refers to this guy. It always refers to this one. So whenever you see sine, you don't need to ask the question, are you talking about the sine with domain from all real numbers, or the sine of restricted domain? Always the sine with all real numbers as domain. You guys follow me? In fact, in your practice, in most of your practices, this function, okay, this function is rarely mentioned. It's almost invisible. Okay, this function is almost invisible. When is it a little bit visible? When is this function a little bit visible? This is when. When is it a little bit visible? Right here. It's only show its cute, pretty face over here. This is the only small face it shows. In all the other situation, okay, in all the other situation, it doesn't show. Okay, so in almost all the literatures, whenever sine is mentioned, it's always referring to this guy. And this function is rarely mentioned, but this function, f function and g inverse, they are not inverse to each other. Do you guys follow me? That's my point. That's my point. So let's look at some examples. Okay. So I think I have given enough introduction, but some of these introduction may look pretty vague to you, or kind of you're not sure if you understand. So let's look at some examples. Okay, let's look at some examples. The first one. Okay, trick 7a. The first one, what does that mean? It says sine of arc sine of 3/5. What does that equal to? Meaning, what it means, 3/5 is the input. The input is the input for which function? The function that immediately applies to it. Okay, and it produces, what does it produce? It produces that as output. This is an angle. So when you see this guy, you should know this is an angle. This is an angle. not only you know this is an angle, and you also know that this angle is between negative pi over 2 to pi over 2. You guys follow me? So when you look at this function, right? When you look at this function, you know 3/5 is the input for ArcSine. And also this input has to be between -1 and 1. So that's what you need to be aware of. Is 3/5 between -1 and 1? Yes. Right, it is between -1 and 1. 3/5 is between -1 and 1, therefore it qualifies to be the input for ArcSine because the ArcSine domain is between -1 to 1. Do you guys see that? Yes. And then you know it produces an output. This is not a special angle, so you don't know what this angle is, even though you can key in your calculator to find the number. But that's okay. We don't need you to do that. We actually don't need you to do that. Okay? What we need you to do is that we want you to realize this whole thing is an angle. So you see that, you see angle. Okay? So you blink your eyes at that thing, what you see? You see an angle. Okay? How does that angle look like? How does that angle look like? Okay. Now I'm going to show you that. Okay, I'm going to show you that. I'm going to bring a picture to help me to do that. Okay, one way to do it, of course, is on the unit circle, and the other way to do it, I'm looking for my unit circle. Okay, I'm looking for my unit circle. Right, I'm looking for my unit circle. If I use this unit circle, what does that mean? Is I know ratio and I'm looking for angle. You guys follow me? I know ratio, I'm looking for angle. All right. Ratio are the blue, the sign ratios are the blue numbers. Because we're dealing with ArcSine, what do we know? What do we know about ArcSine? In dealing with ArcSine, the output is between negative pi over 2 to pi over 2. So I know, you see how important the domain and range are in the whole process. We go about these problems. Is that the input has to be, between -1 and 1. The output is between negative pi over 2 to pi over 2. And what does it imply? It implies the second quadrant and third quadrant. They're out of the picture. They're in no man's land. They're no fly zone. Do you guys follow me? So this angle you are getting, is what? You don't know this angle. Pretend you don't know this angle, okay? Don't touch that calculator. Don't touch that calculator. This angle is either going to be somewhere here or somewhere there. But if it's over here, that means it's a negative angle. Negative angle corresponds to negative sign ratio. We don't have a negative sign ratio. We have a positive sign ratio. That's 3/5. Therefore, you already know the angle is between 0 to pi over 2. Do you follow me? We don't have that blue. We don't have that blue number corresponding to, we don't have a special angle. We don't have a blue 3/5, right? So where should be 3/5? It's somewhere in between. It's somewhere in between. Where would that be? Somewhere in between, okay? So 3/5 is probably, I don't know, I'm just going to estimate, right? 3/5 like 0.6. 0.6, I think it should be between, it probably the terminal is about here. And 3/5 also tells me, the 3/5 also tells me, because this is the This is the point, right? This is the point on the unit circle. On the existing unit circle as we have constructed, right? This point that crossing the unit circle. And it tells me this 3/5, right? This 3/5 also tell me if I can insert a blue, if I can insert a point for this heart, what would that be? And there will be, wait, how come it doesn't type? It will be a red number. It will be a blue number. And what is the blue number? The blue number is going to be 3/5. I'm sorry, I should make these blue. But if I want to make them blue, everything will be blue. So on this point, on this
Lights on.
is a 3/5 for the blue number. The red number is to be found. Well, in this case, we don't need it. We don't need it. Do you guys follow me? That's the information we get from the inside. From the inside. Do you follow me? Does everybody follow me?
Yes.
Yes.
Any questions? Okay. Now, you see, we have another blue number, right? We know the blue number are for sine. So now this blue number is going to be the input for sine. Input for sine. Right? So this angle, which is, which angle is it? Is this guy. So this angle, whatever it is, you don't need to know its actual value. You don't need to know the actual value. You just know that you're going to apply sine to this angle. This is an angle. If you apply sine to this angle, what you get? You get a sine ratio. What is the sine ratio? The sine ratio is the blue number. Therefore, the answer is going to be what? 3/5. Do you guys follow me? This is the process if you go through the ARD, DRA, right? But this also is told over here. That's a story being told. This story tells you, if this input ratio is between -1 and 1, sine of arcsine x is the same as x. So in our case, when we apply this property, okay, when we apply this property, how do we apply this property? We check what is x. What is our x here? Our x is 3/5. Is 3/5 between -1 and +1? The answer is yes. So the answer is right there. So if you know how to apply this property, you didn't have to go through this process we just did. So you can do it either way. You can do it either way. You follow me?
Yeah, I see.
You see that? And of course you would recognize, apply this property directly is easier. But you have to understand that this comes with a condition. The ratio has to be within the domain of ArcSine. Does everybody see that?
Yeah.
Yes.
So some people say, hey, I just want to get the answer. Get the answer quick. Get the answer quick. Please be patient with ourselves, okay? Because if you can go through this whole process covering ARD, DRA multiple times, yes, eventually you will be very quick. But you have to go through that process because that process is what we assess you about. Okay? I know eventually with you guys' intelligence, you're gonna get that very quickly. You realize, oh, right there. Right? So how about you try number 2? So now this answer, what is this answer? So you can do it in 2 different ways. So whole process, what did I use? ARD, DRA, right? ARD, DRA. So when did I use DRA? At the beginning, right? It's a ratio. So from ratio to angle, I'm using DRA, right? Do you guys remember that? I know the terminal is going to be, I know ArcSine is going to produce an angle between -pi/2 to pi/2 because I know the domain and range. The ratio is proper, therefore the angle is going to be between -pi/2 to pi/2. And then we tested it cannot be negative angle, it has to be positive angle. So that process was DRA. The definition of sine, which tell me the blue numbers. Do you guys understand what I'm saying here? I might be repeating myself too much. Am I going too slow or am I repeating myself too much?
I think I understand. So number 2, the answer would be -4 because it's within -1 and +1.
Exactly. You see, you got it. You got it, right?
Okay, I see now.
How about the rest of the class?
Can you repeat what you just said?
Me?
Yes.
Yeah, I said that the answer for number 2 would be itself for -3/4 because it's within -1 and +1.
Okay, gotcha.
Okay, so I'm gonna illustrate that. Okay, I'm gonna illustrate that. Number 2. Jacob was just applying that directly. Okay, so sine of ArcSine, okay, of -3/4. Okay, so let me make fonts a bit larger. Okay. Jacob was just saying that he was directly applying this form. Okay, this statement, right? This statement. You see, these two are in the same form. And that statement says, if, okay, if x is between -1 to +1, right? And you just have to match these two, right? Sine, ArcSine. Oh, sorry, let me rewrite that. Wait, sorry. The color just looks weird. ArcSine. Okay. Sine, ArcSine, and x in this case is -3/4. -3/4, you just have to check is -3/4 is in the domain when this identity applies. And it is indeed. Okay. So the answer is just going to be -3/4. As simple as that. As simple as that. That's the quickest way to get it. However, what if you say, hey, I don't remember, I forgot these identities. You told us you don't want, you try to help us not to memorize, right? If you don't memorize, that's okay. I have a way to show you how to cope with this, right? I have a way to show you how to cope with this. So now with that said and done, you look at this, then you realize, okay, ArcSine takes ratio. You have to understand the basics, okay? ArcSine takes ratio. So this guy is treated as a ratio. Okay, ArcSine. So this guy is angle. Okay, look at this. This is a ratio, will be treated as such, and that ratio has to be between -1 to +1. And this ratio, an arc sine of that, it produces an angle. So this guy is angle. You follow me? This is the angle. Now, so what happened is that you have this input of -3/4 is given to arc sine, that function, right? It produces the angle, and the name of the angle is such. It's not a special angle, I apologize. But it's intentional, right? This angle is going to be between -π/2 to π/2. Okay, this angle, no matter what, is between -π/2 to π/2 in particular, because it's a negative ratio. Okay, the angle is going to be measured from the standard position A, ARDA, clockwise, probably ended up here. I don't know what the exact value of the angle. I just know this is the angle. And there's a blue number for this angle. Okay, what is that blue number for that angle? -3/4. You follow me?
Mhm.
So this angle, this is the angle, and this angle is going to be the input to sine. Okay, just input to sine. And it produces, so if this blue number, we don't, see this little, we have all these blue numbers, right? Those blue numbers are for the special value, but this blue number, okay. I put a pointer here, okay? And this time I'm going to write it. The blue number is going to be the -3/4. And what is the red? I don't know. Well, sometimes you need to know the red, sometimes you don't. In this case, you don't need to know the red. And the blue number play the same role as all of these blue numbers here. And the red number play the same role as all of these red numbers there, which is for the cosine, and the blue for the sine. Do you guys follow me? All right, so these are the two examples that uses the first property. Okay, so let's look at another one. Let's look at the other one. Okay, these other ones would be number 5 and 6. Okay, so the answer is going to be, let me complete this process. Okay, let me complete this process. I don't like unfinished business. Okay. All right, are you guys with me? Okay, so let's look at 5 and 6. Number 5. Previously, okay, some time ago, but even at the beginning of introducing trigonometry, I was telling you all the questions about trigonometry in the world, they're all about either ARD or DRA. Okay, if you understand the fundamental mechanism, which is about input, produce output, what kind of input, what kind of output, domain, range, if you understand that fundamental characteristics, it's either by ARD or DRA. Sometimes in one question, you have ARD, DRA has applied at the same time. So let's look at number 5. ArcSine of sine of pi over 3. Okay, so let me bring that thing with us. Right? And this time it's about this property, right? It's about this property. I'm still gonna address the two different ways to do it because I want you guys to see the ARD DRA. Okay. So now, which one of the two properties applies here? Obviously the second one, right? It's almost like a matching game. It's almost like a matching game, right? ArcSine, sine, x. If x is between negative pi over 2, then the whole thing is going to equal to what? Pi over 3. So these two, it's like a shortcut, right? They're the shortcut. If you know shortcut, great. What if you don't know shortcut? Well, I just do it, all right? So if you don't know the shortcut, what would you do? Right, so we're done. So by this time you're done. Then you say, oh, is that simple? True, but you have to know there's a condition for that property to apply. Okay, but what if I don't know the shortcut? Right, we love shortcut, but we don't always remember the shortcut, right? What if we don't know the shortcut? If you don't know the shortcut, you should know ARD. If we don't know the shortcut, let's look at the ARD. Let's look at the ARD. Right? So what does that mean? Pi over 3 is the input. Immediately, this input is processed by sine, right? Now what? It produces sine of pi over 3. And this is a special angle. What is sine pi over 3? We know sine pi over 3 is a ratio, right? And what is that ratio? Well, it's a root 3 over 2. It's a blue number, right? It's available right there. So you know that even though we get a special angle here, we got lucky, right? The first example, the second example, those are not special angles, but you also know how to do it. So if you understand the true nature of what we just talked about, whether you are given a special angle or not, it should not make any difference to you at all. So this is the angle, right? You see, this is the angle pi over 3. And we have a blue number there. So in fact, you got it. This guy is the same as root 3 over 2. Root 3 over 2. And then the root 3 over 2, which is sine pi over 3, will be used as input for what? ArcSine. ArcSine of root 3 over 2. Okay, I will give you the algebraic expression there, okay? And the output, what will be the output? You know the output, it will be 1 and only, because ArcSine is 1-to-1 function. And that output has to be between negative pi over 2 to pi over 2. So what will be the answer? Pi over 3, right? Okay, so if you don't remember the shortcut, right, that's the process. But algebraically, we don't write it this way. We don't write it this way. You guys don't see these, you know, a lot of these I do in class. Okay. But why do I do this in class? Because I want you to see the composition and I want you to see the flow. And I believe this process will help you understand the computer programming better. But that's, I no longer teach those these days. So, but as some visual, as a kind of visual, I think it might be helpful. Okay. But whether it is helpful, you let me know, because, so algebraically, this is how you express it, right? You forgot the shortcut, you don't know the shortcut, that's okay. But you know sine pi over 3 is √3/2. And arc sine √3/2, so what process is it? From sine pi over 3, that's ARD, right? That's A to D, right? Right, that's ARD, right? Yes? How about from √3/2? Arc sine √3/2. That's from D to A, right? Because you will be, right? From the ratio, look for what? Look for angle. From ratio to angle, right? Angle to ratio. Definition is all about ratios, right? And now you have a ratio from ratio to angle. So that's D to A. Do you guys see that? From D to A, you look for √3/2, right? How many ratio √3/2? You have one here, blue number, because it's arc sine. And you also have another blue number, right? Do you? But you know this is arc sine, don't you? You know this is arc sine. It doesn't get there. That's no man's land. Therefore, the only angle you have is what?
Pi over 3 or √3/2.
That's right. You guys see that? This is the reason we cover all of these details. Now it comes together, doesn't it? Do you guys see that?
Yes.
So that's the algebraic process. So if you know the shortcut, go for it. If you don't know the shortcut, this is the way. And this piece is what? In terms of ARD, I'm going to write it this way. DRA. All the questions you're going to encounter, they're either ARD or DRA. I have not seen exceptions. If you have seen exceptions, please let me know as soon as possible. Okay, so could you guys try number 6? Your turn. I want you guys try number 6 and number 9. Number 6, number 9. What's number 6? Number 6 is arc sine of sine negative pi over 6. Number 9, we have sine, arc sine. We shall have the breakout room, right? I'm sure Farouz is ready.
I'm ready, Professor, and I have a comment. Shortcut is good enough to get the points for this class, but understanding what you are trying to teach us is necessary for future classes.
Absolutely. Such as calculus, right?
Yes,
Thank you, Farouz.
you're welcome.
Because for your future classes, you're not only going to see special angles, you're going to see non-special angles. And you're going to see a lot of non-special angles, right? And you have to know how to handle them. So number 6 and number 9, I'm going to give you a couple minutes. I'm going to give you 4 minutes. Okay, I'm going to give you 4 minutes. Okay, if you want to work with Farouz, go work with Farouz. And he's ready for you. And then we'll come back and we're going to do some more interesting questions. If you decide to stay with me, I'm going to let you do the work just by yourself. Okay. And I'm going to take 1 minute outside the room. But if you know what, how about I give the time to Farouz? Okay. I come back at 9:20. I'll be right back. Okay. I just want to get something to drink. Farouz, you want to take over? Oh, he's in the other room. Okay, he's in the other room. But well, Farouz is in the other room. You can either join him or just stay in this room and work. I'll be right back. Okay. Okay, I'm closing the room. I'm sorry, guys. All right. What's the answer to the first one? Number 6. What is the answer? What is the answer to the first one? What is the answer to number 6? What is the answer to number 6? Hmm? Anybody?
The answer would be negative pi over 6.
That's right. Wonderful. Right? Arc sine, sine, right? If you apply this property right there, that shortcut, you get negative pi over 6 because negative pi over 6 is inside this interval, right? That's a shortcut. How about the first one? Number 9, sorry, number 9, second one.
I want to say it's not possible, right?
That's right, it's undefined. Wonderful, you got it. 3/2 is outside, right? And besides, 3/2 is what? What's the domain of arc sine?
-1 to +1.
That's right. Isn't that 3/2 outside?
Yes,
If it's outside, what do we say?
undefined.
Undefined. Undefined. It's pretty easy, right? All right. So without further ado, let's do a few more challenging one. Okay. So I warned you, they're a little bit more challenging. But you guys can do it. You guys can do it. Okay. So now I'm going to make some choices such as number 15 and number 19. Number 15 and number 19. 15, 19. Okay, so let's do 15. I'm going to do 15, you're going to do 19, okay? Number 15. We have arc sine of sine 3 pi over 4. Having that oh, sorry. Try to expedite the process. Number 15. What do you think?
I want to say it's undefined, right?
Which is undefined?
The first one.
This one?
Yeah, because
Yeah.
it's in the second quadrant of the
Why is
unit
on-
circle.
Is sine defined in the second quadrant?
No, but
Yeah.
looking at 3 over 4, when looking at 3 pi over 4, it is considered in the second quadrant.
Well, I
But it's-
mentioned earlier, whenever you see sine, it refers to the sign we know of.
Mhm.
The
It's
domain
square-
from negative infinity to positive infinity. Sine
But-
3 pi over 4 is perfectly defined. When not mentioned otherwise, the sign always refer to the sign with domain of all real numbers. So this sign of 3 pi is perfectly defined.
Would it be square root 2 over 2?
That's right. It doesn't apply, this property doesn't apply. Because this sign is addressing this guy. Do you follow me?
Wait, but how can you tell the difference then?
I'm sorry?
How would you tell the difference between the first sign and the other sign?
As I mentioned earlier, this sign is rarely used. Never used. Almost never used. It only show a little face here in that form.
That was just to demonstrate the ratio, right?
By this constraint, it referred to this sign. in
That's
this
more like a
scenario-
demonstration, right, of principle rather than like something we use, right?
Right. So whenever sign is showing up in your algebra, in your calculus classes is always refer to this sign.
I see. Okay. So then the answer would be considered 3 pi over 4, or the other version of it, which I kind of forgot.
That's
but yeah.
right. You work from inside. But now I want to show you the process one more time, right? It actually fitting perfectly, right? Because this is the sign. This is the input to the sign, right? This is the input to the sign. It produces an output, right? And this output is going to fall. Sine of 3 pi over 4 is going to be, this guy is a ratio. This ratio is going to be between -1 to +1, for sure. Okay, of course, you know this √2/2. And this ratio is perfectly between -1 to 1, which is in the domain of ArcSine. Do you guys see that? It's in the domain of ArcSine because this guy is between -1 to 1. So it will produce an angle, and this angle is, this final angle is going to be between -pi/2 to pi/2. So it works perfectly in each other's domain. Do you follow me? This is the situation. I know it gets a lot of students confused because they say, oh, which sign is this referred to? Is this refer to the restricted sign, or this refer to the sign we know of? It always refers to the sign we know with domain of all real numbers. Just remember that. Are you guys follow me? It only means that this property does not apply. This property, okay, does not apply because that condition is not satisfied. That condition came from here, came from the G. Do you understand?
Yes.
Okay, I know this is the place. You're not alone. So whenever you see sign, unless otherwise specified, it always refers to the sign, which is right here. Okay? But fortunately, the sine ratio, sine of any angle, remember that range statement about sine? Sine is always, no matter what, for any real number. So this is telling us if you do the sine, and this ratio is always going to be between -1 and 1, which is perfectly in the domain of ArcSine. Do you guys hear me?
Yes.
All right, so let's look at first of all, there's no shortcut here. There's no shortcut, right? There's no shortcut. So what happens here is that you're gonna have what? You're gonna have √2/2. That's the ratio. And ArcSine √2/2, what do we get? Before you even get the answer, you know the angle is going to be between what? Between -pi/2 to pi/2. That's something you must know. Because we have a positive ratio, so that's going to be between 0 to pi/2 for sure. And of course, in our case, it has to be what? Pi/4. In this case, there's no shortcut because this shortcut doesn't apply. Okay, so I'm going to put it here next to it. Does not apply. Okay, it does not tell you what sign is perfectly defined. Okay, so how do you go about this? Algebraically, ArcSine. Okay, inside you're gonna get √2/2. And the next step, You get the answer pi over 4. You're done. So this part is how you show your work algebraically. You don't have to mention the shortcut. Okay, I mentioned it here because we are in that kind of, we're considering whether that property applies. My network has been going lately. Oh, I'm sorry. But you can watch the recording if you miss this part. Okay. Do you guys follow me?
Yes.
So do you want to see the ARD DRA? I want to show you. I want to show you because all I want to do is make sure you guys understand ARD DRA because I know that's going to help you tremendously. Tremendously. Okay. What's the ARD here? Right? What is the ARD here for number 15? The ARD is from here. That's the ARD. Okay, that piece is the ARD, right?
Can you
this
just
piece
repeat? Can you repeat
is
what
ARD,
ARD
right?
means?
I'm sorry?
Can you repeat what ARD means?
A is angle measurement. R is reference angle. D is definition.
Okay, thank you.
Okay, what are angle measurement? Counterclockwise, positive angle. Clockwise, negative angle. Reference angle, the positive acute angle between terminal and the x-axis. Definition. Definition in this case is sine. Sine is y over r, with that stage set. You got it?
Yes.
So this piece, okay, this piece is ARD. ARD in that order. ARD. Why do I say ARD? Right? You see the angle? Angle is the input. Okay? You measure from the standard position, and that's the terminal. 3 pi over 4. R with the reference angle. The reference angle is pi over 4 right here. Right? ARD definition. Sine 3 pi over 4. You take the blue number. That's the ARD I refer to. You follow me? And the next piece is DRA. Is DRA. Okay, from ratio to angle is DRA, right? So we know the ratio is √2/2, right? We know the ratio is √2/2, right? So where do we see ratio √2/2? We have one here, and we have one over there, right? So they each have a terminal. There's a terminal here. But which angle should be the one we should have? Well, ArcSine, the range of ArcSine tell us. The range of ArcSine tell us, it also tell us this quadrant and second quadrant, third quadrant are a no-fly zone. Therefore, this is the angle, that's DRA. Do you follow me? The ratio is from the definition. And from the definition, you have two terminals. That's R, A. Do you follow me? That's the DRA I'm talking about. Do you get it?
Yeah.
So if you can identify the nature of these questions, you will be invincible. Invincible, trust me. Okay, so that's D, R, A. Okay, or my preferred way to write it is that I just reverse it. Okay, so ARD, right? ARD. We have approached the end of the class, all right? From DRA basically means from ratio to angle. Do you guys follow me?
Professor, is it today Thursday?
Today's Thursday. Oh yeah, we actually have up to 10:05. I'm sorry. Okay. Do you guys get it?
Yes.
Yes.
ARD means from angle to ratio. DRA means from ratio to angle. Do you have any questions in trigonometry other than these two types? As far as I know, none, zero. All the questions are in these two categories. You just have to master these. That's why I'm doing these over and over and over again, because I want you guys to do the same, to train yourself, Okay. All right, so shall we take a break?
Sure.
Well, if you guys up to it, and you can take a break. But you guys, for those of you who get really excited about this, how about you try number 19? Shall you? Would you like to try number 19?
I think I have the
And
answer.
I leave
for it.
number 15 here. Okay, so break time. 5 minutes. 5 minutes also, or so. If you like, try number 19. Okay, I'll be
Would-
back. I'm gonna give you
Number 19,
Lisa, you
Professor,
okay?
can you write number 19?
Okay.
Yeah,
What's happening?
nothing.
number 19. Number 19 is arc sine.
Hmm,
Your voice is kind of froggy.
oh.
Okay,
Miss Wang, would the answer be negative pi over 6?
good job. Very good job, Jacob. Is that you, Jacob?
Yeah, I just did the math quickly as I can in my head.
You see, you're getting better and better at this, right?
He's
Are you
getting
going
invisible.
through the ARD, DRA yourself?
Oh no, what I did is I simply did 7 pi over 6 in a circle, and then it was 1/2, then I connected 1/2 into arc sine, which either lead into 11 pi over 6 or negative pi over 6. But since 11 pi over 6 isn't the correct answer, you would do negative pi over 6, so that would be the answer.
All right. So would you mind to show your work, write down your work and upload? When we come back, I'm going to show it to the class if you don't mind.
Okay.
Okay, so I'm going to take a break. And you too, please, because I know some of you may need a break.
Can I get the cash for the grill?
Mm-hmm.
Is that okay? 'Cause I'm gonna go get something. I have to drive somewhere right now.
So let's come back at 9:45. Okay, so I gave myself a deadline. I gave you a deadline, but you can work on that number 19. Okay. All right, guys, welcome back. Did Jacob send the work?
I'm going to soon, but like the
Take your
way
time.
the way I did it, it kind of shows it like the way I did it in my head or how I think of process. Would that be okay?
No problem. You know, first of all, I appreciate you share the work. And secondly, you know, I'm gonna critique it, right?
Yeah.
But nothing personal. I love each one of you, but I just want you guys I want to make you work better if I can. If your work is already perfect, then I also acknowledge. So, but I especially appreciate people who contribute their work. Of course, I cannot look at everybody's work all the time. It just, in the circumstances, I think I'd like to see an example. If you're not ready, and
I just sent it on Pronto
Is
for the
this
main
it?
chat. Yeah, I think I sent it right now.
okay, got it. I got it. I see it. Thank you, Jacob. All right. Arc sine pi 7 pi over 6. Okay. So he would do ARD and he will get negative half, right? So put an equal sign there, and you have equal sign over there, just make it larger. It's I'm sorry, I forgot. Did I? So is this a negative sign, Jacob? Is this
Yeah, that's a negative.
sign?
That's a negative sign. I had to like erase it because like the first time I did
Yeah,
it looked
then you
kind of bad.
a equal sign in front of it. It's just the negative sign is not invisible. It's almost look like an equal sign, okay? But I will show you the other version to the class, okay? But on this part, okay, even though you cross it out, if I were you, I would remove this piece completely,
I see. Okay.
okay? Just remove. Okay, just remove, okay? You guys got it? So I'm gonna show you how I would show the work. Ready?
Mm-hmm.
Okay. How I would show the work. Thank you for sharing. Okay. If I am to do this, right? I will do the arc sine, right? I'm going to show you how to do it, right? So ARD. You can do this mentally. I'm not saying you cannot do this mentally. You can do this mentally, but because I'm teaching in class, I cannot do it mentally. Okay, I have to show it to you because I'm supposed to be helping you, right? So when I see 7 pi over 6, right, this is a special angle, right? So this is A, right? So this is A, so this is positive angle, ARD, this is A. This is a pi plus pi over 6, that's 7 pi over 6. So this angle, this entire angle is 7 pi over 6. I'm applying the angle measurement, positive angle, right? And what is the R? The reference angle is pi over 6. This is the reference angle, right? So this angle is the A. A, of course, is 7 pi over 6. This is what I refer to as ARD. And we happen to have a blue number waiting for us there, right? So that's how you get the negative half, right? And from ArcSine negative half, from ArcSine negative half, you already know the definition, right? You know that that's a sine ratio. You know the ratio. You want to find the angle, right? We want to find the angle. Because this is ArcSine, we know that this is going to be what? These two quadrants are gone because the range of ArcSine is between negative pi over 2 to pi over 2. You can only measure the angle either this way, hit the wall, or that way. No entry to the no-fly zone, okay? And we have a negative ratio, so over here. And what is the angle? So that's negative pi over 6. That's the DRA. Do you guys follow me? ARD, DRA. Got it?
Mhm.
How's everybody? Did everybody get it?
Professor, oh, you erased it. You
Oh, sorry,
labeled,
I can do it again.
yeah, you labeled A, you labeled the R, you did not label the D.
I'm sorry?
You labeled ARD on the unit circle. That was, a visual representation of what you are trying to teach us, ARD. So you
ARD,
labeled,
yeah.
you labeled A on the unit circle, 7
Right.
pi over 6. Then you label the reference, which is the acute angle,
Right.
and negative 1 over 2 was the D, wasn't it?
D is a definition. In this case, the definition is sine definition.
Is a ratio, is not a ratio?
It's a ratio of y over r.
Yes, which is negative 1 over 2 in this case.
That's negative half.
That is, that is the D, isn't it?
Yes, that's a D.
Oh. That
Okay.
you labeled A, you labeled R, that labeling D would complete the visual representation of what you are telling us, ARD.
Yeah, that's A,
Yes,
right? That's A. Reference angle, R, the positive acute angle, this is pi over 6,
yes.
and D, the blue number,
Thank you, Professor.
ARD.
Thank you.
So that piece is ARD. And how about the next piece? Oh, sorry, I have a typo there, 6. Right, the next piece is DRA. Okay, the arrow reversed in order. Do you guys get this part? Please ask me, because this is like an abstraction, summarize abstraction, right? So you can classify your question. Once you start to classify your question, you realize you only have 2 types. You only have 2 types. Got it?
I have a question.
Mm-hmm.
Why is the angle negative pi over 6? Because if you can only label it in the first and fourth quadrant, and pi over 6 is positive in the first quadrant, why would the answer be negative?
The angle is negative because for the negative ratio of a negative half, the sine ratio, to get to that place, because it's ArcSine, the range of ArcSine has to be between negative pi over 2 to pi over 2. You cannot measure this way. Okay, that's outside negative pi over 2 to pi over 2. Right, because this is related to the function we're talking about. This ArcSine has a domain and range. Right, the ArcSine domain and range, domain is between the ratio between -1 to 1, the range is between negative pi over 2 to pi over 2. So your answer has to be between negative pi over 2 to pi over 2. It cannot be any other angle. That's the one-to-one we talk about.
No, I know that. I was talking more about like the answer. I thought it was going to be just pi over 6
No,
because
pi over 6 will be here. Right? You
Right.
have a negative pi over, and we have a negative half.
okay, I got you. So
Right.
but you wouldn't use the 11 pi over 6. You would just use negative pi over 6 because that's the equivalent like reference angle to using the ratio -1/2.
You cannot use 11 pi over 6 because even 11 pi over 6 is outside the range of ArcSine.
Gotcha. That would be like if you drew a circle like almost all the way around and created an angle.
That's right. You cannot
Okay.
fly over the no-fly zone.
Gotcha. Okay, cool.
That's what we meant.
Okay, I got it. You can move on.
Thank you. The range tells you your answer cannot get out of it. The range means range. It means business. Okay. The domain and range is the ultimate, is what it tells you what your input can be from, and it tells you what your output is to be expected. It cannot be outside. Okay. Sometimes the domain and range are natural occurring, like in the exponential and logarithm. But in the domain and range for ArcSine is mainly imposed. The range is mainly imposed. Are you guys with me? Is imposed, but imposed for good reason. Then I would encourage you to keep that question in your mind. Why the range is imposed as such? Okay, you need to keep asking that question and until it's completely clear to you. Okay, so I'm not going to give you all the answers right now. I want you guys to think about it because as we progress, you're going to see it. You're going to see it. All right, so without further ado, I think we shall do one more and then we close today's lecture. Right? So this one I wish to work with you is number 23. Number 23. Are you guys ready for number 23?
Yeah.
Would you like to try it? It's ArcSine.
Would it also be negative pi over 6 as well?
Think again.
Okay.
Okay. I'm not going to answer right away. 23, 25. Okay. How about we do 23, 25? By this time, I hope you guys agree with me that it's all about ARD, right? It's all about the proper use of ARD and domain and range, of course, which is the domain and range it's like the shadow of the function, right? It's like our shadow. For example, we go everywhere, our shadow come with us, right? Yes, we all have a shadow, right? It's inseparable from us. Okay, it's just like our shadow. It comes with a rule. Every rule has its domain and range. Every rule has its domain and range. Now you take a second look at the basic one table, right? Every rule has its own domain and range. Some of those are natural occurring. Some of those are, we have to set up some rules. We set the stage. like the last 8 functions, the last 8 trig functions we're working with, these are the very complicated rules. Okay, it caused a lot of headaches for our students. And all I want is just to clarify. Okay, all right. We don't have much time left, so I'm going to go ahead, okay? Jacob had an answer to it earlier on. But I don't want you guys to get distracted. I don't want you guys distracted. I want you guys to think for yourself. Do you agree with Jacob? Can you tell your answer to the class right now?
Yeah, for number 23, I believe it should be negative pi over 6, right?
Okay, so he thinks that the answer should be negative pi over 6. Okay, I have answered him in private message. So by this time, I think we can go over it, right? The first piece is ARD, right? The inside is ARD, right? Yes?
Mhm.
And how do you measure the angle? Clockwise. Boom. This is A. And what is R? R is pi over 6. ARD. And what's the blue? Negative half. Right? Yes?
Yeah.
Negative half. And then what? We're working with ArcSine, right? ArcSine, no matter if the ratio has to be between -1 to +1 in the domain, and the range, your answer has to be between negative pi over 2 to pi over 2. Do you follow me? So what would that be?
Negative pi over 6.
That's right. No fly zone, right? No fly zone. Therefore, what you get? That angle is going to be negative pi over 6. Good job, Jacob. All right. Are we good? How about 25?
I have the answer. Do you want me to say what it is?
All right. I can see some people are very good at using this now, right? So let's go by the steps. Right, so this is, unfortunately, I don't think we have time to do the loading, uploading, okay? So I'm just going to go for it. Jacob has an answer. What's your answer?
So it's the same thing.
Same thing?
I got pi over 6.
So someone says the same thing, someone says.
Oh, no, it would be pi over 6, right?
That's right. I love it. I love the way you self-check. Okay, I love the way you check for yourself and then you think for yourself. That's what we wanted. Okay, being correct or not correct is one thing. Being know how to approach the question is another, right? So even though we have a negative 7 pi over 6, if we know A, right? If we know A, we will measure the angle. How do we measure the angle?
Clockwise?
Clockwise. Beautiful. You guys really got it. I'm so happy to see this. Right? So what is A? That is A.
Negative 7 pi over 6.
Yes. And the reference angle, what's the reference angle? Pi over 6.
Pi over 6.
And was it D? Definition, that ratio is half.
So since the ratio is positive, that's why we can say it's pi over 6 and not
That's right.
negative pi over 6.
Correct. You got it. So the next step is that we have arc sine, right? Half. right? Because we're dealing with ArcSine, it has its own domain and range. Now the ratio is positive, and we have a no man's land, right? These pieces in terms of ArcSine, they're out. So for the positive half, there's only one angle corresponds to it because this is a one-to-one function, right? This is a one-to-one function. So we have no choice but taking this angle. This angle, how is it measured? From the standard position counterclockwise. So that's the DR, that's a DRA. Do you follow me?
Yeah.
So I hope that everything's become clear to you by this time. Do you have any questions?
The one question I have is for the homework.
Yeah? Homework.
Are we doing trick 7 for homework?
Yes, you're gonna do trick 7 for your homework, but you're only going to do related to the sine ArcSine. Anything
Okay.
related to the sine ArcSine. And the rest are optional.
I see. Okay. Are you gonna go over the best in class on Monday?
Of course. On Monday, we're gonna do arc cosine.
Okay. I see.
Yeah, I just don't want to.
Okay, we're going to do arc cosine on Monday. Okay, but once you get this piece done, we're good. If you understand everything about sine, you understand cosine, arc cosine much better. But there'll be differences. Okay, there'll be differences, but the ideas are the same. So we will follow the same trajectory, but there's differences. There are differences, okay? Don't think that they're the same. No, they're not the same. They each have their own differences because there are different rules, okay? So I'm gonna head to my office hours, and that's all for today. And I will spell out the homework for today. And I'll see you guys on Monday, if not sooner. If you have any questions, so please don't hesitate to reach out to me 24/7.
Or me today from 3 to 6 p.m. Math Study Center.
Thank you, Farouz.